So we talked in the last video about when you already know a solution, or when you already have a point, how to figure out if it's actually a solution. And now I'm going to talk about how we can find the one point that will be a solution. So there is only ever one point that will be, or one x and one y that will be a solution to a system. And the chances of you guessing and checking and finding that point are very small. So we're going to talk about ways for you to find the solution. And the first way we're going to do it is going to give you an approximate solution. Sometimes it will be an exact answer, but most of the time when we use graphing to help us find the solution, it's just going to give us an approximation of the solution. Okay? So when you are finding the solution to a system and you're doing it by a graph, okay, it says when you have a graph of two different linear equations, so they have to be different, the solution of the system is the point where the two lines intersect, if they cross at all. Okay? So it's where the two lines intersect if they cross at all. Okay? So there is one situation where they will not cross at all, and we're going to look at that in a minute, and so that would mean there was no solutions. But if you graph the two different lines, the solution is where they intersect. Okay? So when we look at these examples, we're going to need to graph each equation. Okay? Most of the time, like I said, our equations will be given to us in slope-intercept form, and we'll just have to graph them that way. So y equals negative 3x plus 4 has a y-intercept of 4 and a slope of negative 3. I'm going to go ahead and use my line tool here to make that line. And then 6x minus 5 has a y-intercept of negative 5. 1, 2, 3, 4, 5. And a slope of 6. And then use my line tool here. So I've got my two lines, and I can see very easily that there's only one spot here where they will intersect. So my solution, the point that will work in each of these equations, is where they intersect. So the solution to the system is not just the graph, but you have to write down the coordinate where they intersect. So 1, 1. Or you could write x equals 1, y equals 1. Okay? That is the only solution that will work. If I check it back into my equation, negative 3 times 1 plus 4 equals 1 will be true because negative 3 plus 4 equals 1 works. And in our second equation, if I put 1 in there, 6 times 1 minus 5 equals 1 gives me 6 minus 5 equals 1, and that works as well. So an x and a y of 1 work in both equations, and I found that out by graphing. Okay? Now, sometimes we're given an equation, for example, like this, where it's not in slope-intercept form, so it's not easy to graph. So what I'm going to do is I'm going to solve this for y. So I'm going to subtract 3x from each side to give me that 3y equals, I'm going to do negative 3x plus 6 instead of 6 minus 3x, and then divide by 3, and I get y equals negative 1x plus 2. And now I can cross this one out. In my system, I would have negative x plus 2. That's my system. Okay? So I'm going to do x minus 4. That would be a y-intercept of negative 4 and a slope of 1. And then I'm going to do negative x plus 2, starts at 2, has a slope of negative 1. And then to write my solution, I write it as a coordinate, 3, negative 1, or I write x equals 3, y equals negative 1. Because that is where they intersect. That's the only x and y coordinate that will make both equations true. Okay? Now we talked about special cases here. If I look at these two equations, 3x minus 2 and 3x plus 1, if I graph those, okay, if I graph the first one, let's graph this one in blue. This would be a minus 2 and a positive 3 slope. And then I graph the next one. Let's graph this one in green. I have 3x plus 1. These lines are parallel because they have the same slope. So they will never intersect. And this goes back to when we were solving equations. When we had equations like this, we said that it was possible for there to be no solutions. Oops. That would be like if 3x minus 2 equals 3x plus 1. If I subtract the 3x, I get negative 2 equals 1, which is not true, which is why there's no solutions. Okay? So these two will never be equal because they have the same slope but different y-intercepts, so they have no solutions. Now if I look at this one, it's given it to me in this weird form again. It's called standard form. And I'm going to solve it for y to help me graph. And as I'm solving it, what I notice is what happens is it becomes the same exact equation as before. They become the same thing. That becomes a y equals negative 2x plus 4 and a y equals negative 2x plus 4. So when I graph them, there's no way to graph them other than on top of each other. They're the same graph. Okay? Every single point that you put in for x and y will work for both equations. So technically, I would say this is not a solution. This is not a system of equations because it's only one equation. However, a lot of times people will also say that it has infinite solutions because basically all values of x and y that I put in there will work for both of the equations. Okay? So I want you to graph graph these lines, the system of equations, and provide an approximate solution. So remember, your solution is either going to be a point or it's going to be an x equals and a y equals. Okay? Bring that to class with you. Remember to fill out the form if you have questions to let your teacher know before you come.